Hello and welcome to another video of Vidhai. I'm Ryan, a volunteer from Vidhai in the team of Exams Vidhai where everything is possible. This is the second video of the chapter Atomic Structure. So, in the previous video, we have been looking into the introduction, Dalton's atomic theory, fundamental particles, and Thomson's atomic model. Now, in this video, we'll be learning about the valencies. There are types of valencies, valencies of ions and variable valencies. So we'll be taking a look into these. What is valency, you may ask? The electron revolving in the outermost orbit is called valency. So when you have this atomic structure, this is more accurate, but when you flat it out into a planar surface, right, you can see orbits that are going around the nucleus, and this outermost ring that you see, and if you count the number of electrons here, and that's the valence electrons, and the valency is the number of electrons needed to achieve a fully filled shell. So for this shell we have a valence electron of 1 2 3 4 5 6 7 and 8 valence electrons. The type of valency are generally to donate the electrons whatever they have outside the ring, or accept the electrons from the open source which is donating the electrons. So the atoms that donate the electrons are said to have the positive valency, which are usually metals like sodium, potassium, cesium and lithium, while atoms that accept electrons are said to have negative valencies like non-metals. So you have oxygen, nitrogen, you got chlorine and other materials as well. An ion or radical is classified as monovalent, divalent, trivalent or tetravalent or pentavalent even. So you can just add on names if you want, but it's practical that you only have till 4 for now, right? Because there's no more donation more than 4 or no more accepting of electrons more than 4. That's rather the minimum number of electrons that you require to form a fully filled shell. So you have this hydrogen, right? This one outer shell of hydrogen needs one more electron, meaning its valency is 1. This oxygen has 6 electrons in its outer shell, meaning it needs 2 more electrons in its outer shell. In order to know how much electron is needed for the outer shell, you will be learning it in the future class. For now, just learn and remember the data of what is the valency of what elements. So you have ions which are negative radicals. So you have this -1 and -2. Those are the valencies, right? You have been wondering what is this -1 and -2 be like, right? So those are the valencies that is required. So you have plus when the electron goes away from the atom, meaning that electron is a negative charged particle. So when you lose electron, you gain a positive charge, and if you gain electron, you will gain a negative charge. For example, hydrogen valency is 1 and sulfate ion, this is a sulfate ion, is -2, meaning that it needs 2 hydrogen atoms to be donated to the sulfate ion in order to form sulfuric acid that you see here, H2SO4. Thus, since it's formed with 2 hydrogen atoms, its valency is also said to be 2 because valency of hydrogen is 1. So you have this another concept of variable valencies. This happens due to orbitals, which you will be learning in your 11th or 12th standard. So you have copper, which has +1 and +2 here, right? This is called as cuprous, or the +2 will be called as cupric. Now cuprous and cupric, so the one which is having the higher value is written with an IC, while the lower one is written with OUS. So let's take next element of iron, where Fe2 plus and Fe3 plus, and if you look at Fe3 plus, it's ferric, and for Fe2 plus is ferrous. Similarly for tin and mercury as well. You can find this text table in the textbook as well, so don't worry. So before we conclude this video, I would like to give a gist of chemical formulation. So the chemical formulation is a shorthand notation of a compound or a molecule. Remember that H2SO4 is sulfuric acid. We'll be looking into how we got that, right? So before we get into writing it, I want you people to take your textbook or look at these tables in these slides and learn the valency of that particular element. So you have chloride, which is 1, sulfate, which is 2, nitrate, which is 1, and you remember the names of these like Cl, SO4, NO3. Now, why do you need to know this valencies is rather important, because if you ask in the test, you can easily find the formula using these valencies, and this number depends on how much hydrogen atoms you have here. So listen, sulfide has 2 hydrogen atoms, meaning it has 2 valence electrons. Oxide has 2 hydrogen atoms, which means oxygen is 2 electrons in valency. For same for carbonate, it requires 2 hydrogen atoms, which means 2 in valency. These having negative signs are called anions, and while you have these metals here which are combining with chlorine instead of hydrogen, chlorine, if you count the number of chlorine, you will get the valency of the ion, and those are called cations. Notice that cations are fully metals and anions are fully non-metals, apart from this exception where it's a non-metal here that we'll be learning in the future classes. For now, just remember this sodium is 1, ammonia is 1, and remember the letters and the numbers that is written for the formula. So let's use this table and try to form the chemical compound for calcium chloride. So first step is to write the symbol of calcium and chloride separately. So do we have calcium here? Yes, you have. So just write the symbol of it, Ca. So you have Ca here. Now then you have chlorine. So what is the symbol for chlorine? You will be having it here. It's Cl. It's not given here, rather it's actually given here. You have Cl here, chlorine. So Cl, write Cl, and then write its valency above the element that whatever you have written without the negative or positive side. So for Ca, that is calcium, it's 2, so have the 2 right there, and for chlorine you have 1 here, so write 1 there. And your third step is to interchange those values valency of those elements. So you have 1 to calcium and 2 to chlorine, and then you have 1 calcium and 2 chlorine. So CaCl2 is the chemical compound for calcium chloride. Now let's take another example for lead 2 oxide. So same here, we'll be writing the formula of lead and oxide, and then we'll be writing the valencies of lead and oxide, which is 2 and 2 respectively. You notice that 2 and 2 can be easily cancelled out when they divide each other, so they are in 2:2 ratio, which is 1:1 ratio. So you got to write 1:1 because they can divide each other. So you have 4 and 2, you can cut them off and write 2 and 1. So you have 1 1 here and interchange those 1 1, and then you have PbO. Here lead has a variable valencies of plumbous and plumbic. So you have Pb plus 2 and Pb plus 3, and this 2 actually mentions the number of valencies it has. And for lead 3, right, you can write 3 here and 2 here, because it's not 2 anymore, it's 3 here, as you can see here, and then you can interchange to get Pb2O3. Now for naming the chemical compounds. In naming the chemical compound, when the compound is having a metal and a non-metal, the metal name is written first and the non-metal name adding a suffix "ide" to it. So I have a metal sodium, and then you have the metal chlorine, and chlorine plus ide is chloride. So you have sodium chloride. Similarly for silver bromide, while Ag is silver and Br is bromine, and bromine plus ide is bromide. Now, if the compound is containing a metal and a non-metal with an oxygen, then you have to add 8 if it has more oxygen atom and 8 if it has less oxygen atom. So here you have 4 oxygen atom in the first one, and you have here 2 oxygen atom in the second one. So it's sodium sulfate because it has 4 oxygen atom, and sodium nitrite because it has two oxygen atoms. And the third and the final one is if it only contains nonmetals, you have to write mono, di, tri, tetra, penta, hexa, and you can so on go on with these words to notice that how much nonmetals is being attached to it. So you have sulfur is attached with two hydrogens, which means dioxide. Di means two, so sulfur dioxide. And then you have nitrogen, you have two nitrogen and five oxygen, so dinitrogen pentoxide. Pent means five, di means two, like before. So this is more or less the answers to the activity given in your textbook. I know this could be a hard one to solve because you guys are new to it. So here is the answers to it, so you can get practice to it. So the first one utilizes this particular definition. The second one uses the second one. The third one uses the first one. The fourth one also uses the first one. The fifth one uses the second one. The last one uses the last one because that's a simpler case for it. Because oxygen here, when it's only oxygen, you have a different case there. So with that being said, let's move on to the question to end this video. So the chemical name for Na2SO4 is what? You have seen this in the previous slide that we have discussed. So go ahead, take your time. You can even reverse the video and see for the answer for yourself and come back to here if you don't know the answer. Or you can pause the video, you can question yourself as well. And the answer to this question is sodium sulfate. The reason is because it has more oxygen atoms, so you got to end the suffix with 8, and you have sulfur, so sulfate, and then you have sodium here, so always you got to write the metal name first and then sulfate, so sodium sulfate. And that concludes the second video of the chapter atomic structure. Please check the description for extra questions and lecture notes for this chapter. And don't worry, all the text and the tables that I've shown in this slides are directly from the textbook and no other source. So do go through your textbook if you have any doubts. And the images are from Google Images, so don't worry as well. And also remember to go through the points to remember and glossary in the back of the lesson. Thank you for attending.